Hello everyone, welcome to this presentation. This video is about surface area of prisms, and the question we're tackling today reads: the figure below represents a pentagonal prism of length 12 centimeters. The cross-section is a regular pentagon, center O, whose dimensions are as shown. So we have the figure as shown. We have the cross-section here is a pentagon, and the dimensions are as shown there. Find the total surface area of the prism. So the total surface area will be the total area of all the faces of this solid. So I want us to begin with the cross sections. So let's consider the cross section here, which is a pentagon. I want us to recall this. If we produce one of the sides, this angle here is known as an exterior angle. So we can call it theta. And then, given the center of the pentagon, if we join from this vertex to the center, let's call it O, and from this vertex again to the center, then the angle subtended there should be equal to the exterior angle, theta. And from this, it is important for us to determine the size of the exterior angle for a regular pentagon. So an exterior angle is usually calculated as 360 all over the number of sides of the regular polygon, and the number of sides for a pentagon is 5. And this should give us 72 degrees. That means for this particular diagram here, remember here we have as 4.25 as given in the diagram, and this should be equal to this other length, which is 4.25 centimeters. And then the angle here we've already seen is 72 degrees because the exterior angle is 72 degrees. Now the point here is to use this triangle here to determine the total area of this cross section. We will get the area of this triangle and multiply by 5 because there are 5 similar triangles in this pentagon. Remember, if we join all the vertices to the center, we will have 5 triangles, 1, 2, 3, 4, 5, and they're equal in size, and that is in area. So just get one of the areas and then multiply by 5 to get the area of the cross section. So area of cross section here is obtained as follows. Remember, for this triangle here we have two sides which are 4.25 centimeters in length, and the two sides have an included angle which is 72 degrees. Now with that, we can therefore get the area using the sine formula, that is a half AB, and our A and B are this 4.25 and 4.25, those two sides which have an included angle. So we have 4.25 times 4.25, that is 4.25 squared, and then we multiply by sine of the included angle, which we found to be 72 degrees. Remember, this should be for one triangle, and there are 5 triangles in number. Remember, it's a pentagon, so we multiply by 5. And if we work out this, we should be able to get 42.946. Now, take note that that is just the area of this cross section, and because this is a prism, for a prism, the cross section remains uniform all throughout the length. That means that the size of this cross section here should be equal to the size of the other cross section at the other end. So that's what makes it a prism. So if we have to determine the area of cross sections, we'll have to multiply the area of one cross section by 2, and that gives us, so we have 42.946 multiplied by 2 because there are 2, and that should give us 85.892. Now that is for the cross sections. Remember, we have these other sides. We have these other faces. There are 5 in numbers, and remember, we are told that each side of the pentagon here, that is of the cross section, is 5 centimeters, and we are told that it's a regular pentagon. Being a regular pentagon, that means all these sides are 5 centimeters. So that means that if this is 5 and the length of the prism is 12 centimeters, then all these other faces have the same area as the area of this side. So if we have the area of this side, remember it's a rectangle, it's rectangular in shape, so the area is length times width, and then we'll have to multiply by 5. So area of rectangles, area is given by length times width, and that is 12 by 5, and then we multiply by the total number of sides, and that is, rather, total number of rectangles present, that is 5. And that should give us, this is 60. 60 by 5 is 300. And that therefore means that the total surface area will be the sum of all the areas, and that is 85.892 plus 300, and that should give us 385.892 square centimeters. And that is the total surface area of the prism as desired in this question. Now, that marks the end of the solution to this problem. If you're new to this channel, please make sure you subscribe for more content like this. I want to thank you for watching. Thank you for staying with me till this end, and bye for now.